Hi. The objective of this ICP is uh, predicting the text by performing the text generation using the model that was provided in ICP6. Here we imported the modules that are required like TensorFlow, NumPy, OS time, and downloaded the data from the online. Here we read the data that was taken from the online using the open function, and the length of the characters in the text file is these thing 9993 characters. And here we're printing the starting lines of the text, or starting 500 characters of the text. The unique characters in these tags is like 62 characters. So we just sorted and do that, and then we just process it and vectorize the text. Before doing this, we are mapping the strings to a numerical indices and then index to the characters. So we are first I use the character to in the variable to just mapping characters to the indexes, and then next to characters using the NumPy array. The below is the output. The task is we are taking the sequence of characters, and then from this input as input taking as input, and we are predicting the next character of the sequence. So here the sequence of the length is taken as 100. We have used the data.dataset from tensor slices function to convert the vector into the indices, and this is the output. And the next is a batch method. Batch method helps us to easily convert these individual characters into the desired size of desired specific size that we have specified. And then here we use the function character data set batch, and this is the output. For each sequence we are dividing duplicating like input text and target text, and shift it to the right side. So we just chunk the text using the split input target function, and we can see the output that here it is up to the def, but in the target data it predicted the next. This is the example. Oh, we creating the training batches with the batch size 1 to I just changed it. This is my first change. I just changed the batch size is 128 and taken the buffer size is 10,000. We split the we are shuffling the data and then building the model. So we are building the model. We are taking the layers as embedding layer and GRU layer, and I added that dropout layer and the dense layer using the sequential model. So vocabulary size is like a unique characters length, and embedding 256 and units 1024, and we have taken the drop rate is 0.1. So these are three change. These are the total 4 changes I have made. I had added we had added the layers embedding GRU dropout dense, and this is function. Now we just run the model to see how it behaves. So this is the shape of the model. Batch size is 128, sequence length is 100, and vocab size is 62. In this the sequence length of the input is 100, but model can be run on any length of the batch size. So sequence length. This is the shape of the model, and then here we just sample the indices. This is the output using the categorical and squeeze functions, and here use the loss function to calculate the a loss of the data. and the scalar loss is 4.12, and the shape is 128, batch size, sequence length, and vocab size. And then compile the model using the optimizer Adam, and loss is equal to loss, and then configuring the checkpoints using the function tf.keras.callbacks.model checkpoint to ensure we are ensuring here that the checkpoints are saved while training. So, and we just executed the training model with epochs is equal to 11. Here we are restoring the latest checkpoint to make the prediction, to keep the prediction step simple. So we used a batch size as 1, and final after this the batch, so the model shape is this one, below is the output. And the next we just define the function to just generate the text, to just predict the text. Here it was taking the model of the what was we built previously, and then taking the string from the text. Here I given the string, start string is equal to BIRON. So and then number of I just given the value as 1000 characters to generate, and then input avail the text generated is called empty string, so we can just append the predicted output which is coming after the model into this text generated file, text generated list. So it is generating the text. So after running this thing, below is the output I am getting using the start string is equal to BIRON. This is the final output. Thank you.